Hey, good morning, good afternoon, and good
Hey.
evening, everyone, depending on where you join us from today. Today, we are going to talk about a new programming language, and for that, we want to welcome Sine. Hi, Sine, how are you? Are you
I'm
excited?
I'm very excited and fine. Thank you.
Great
Yeah,
to hear that.
Where
And
are you located, Sina?
yeah. I'm in Copenhagen in Vandløse, which means something like Waterloose
okay,
in English.
that's
Yeah,
an
it's a little
exciting
sub.
fact.
Yeah. It's a little suburb out of Copenhagen,
hmm
um, which is not so exciting, but really nice.
No, but that I didn't know that it means that. So that at least is something
Yeah.
new to hear
Yeah.
about. But we will hear about a lot more new information. And before we get there, I also heard something about that you are an author of a book. Could you tell a
Yes.
bit about this book, please?
Yes, and now I haven't got it here with me. No, but it's I'll find a picture. It's a book called Kvinde kan i kode. In English, it's called like a woman's code book, and it is not because it's only for women, but it's more because I noticed that there are so many of the programming books we have already, which are very much on cars and airplanes and so on. So I thought we should try to broaden out the palette a bit. So I try to make a woman's it's dangerous to say women's, but to have it with a to have it in more colors than it is so far, so to say. So I have both some introduction to computational thinking and what is it really, and I'll use a bit of it in my presentation, and then also some which I actually really enjoyed making was to make some biographies on historical programming women, and there are quite a lot. I figured out.
Okay,
Yeah. So there's
that's
like
nice.
like the pre-inventor of COBOL was, for example, a woman called Grace Hopper, who also invented the term computer bug, for example. So there is there are a lot of uh, women in history, and I just thought that it was interesting because I had this idea that we are very few even who are who are here in computer science, but like 50 years ago it was a woman thing, and I thought that was actually interesting.
That's true. Yes, and
Yeah.
that's very true. Okay, that's really interesting. So, where can people find this book if they want to read it?
At for example, Saxo.
Okay.
Yeah, it's like a book Danish ebook store. It's in Danish, so I think if you don't speak Danish, it doesn't give much sense. Makes much
I mean,
sense
it's
to have
never too late to learn a new language, right?
yeah, that's true. Yeah, then you can both learn to program and a new language.
Exactly.
Yeah, so but I
Yes.
have no programming languages as such there. I have only block programming and then actually a bit of Excel, because I thought many people they are maybe know how to do something in Excel, and then I try to translate it into what is it
Mm.
like when you program. Yeah.
Okay, that's really interesting. And now that we talked a bit about that, funnily, that okay, we can anytime start learning a new language. Today we're gonna actually start learning a new language. And before we get to that, we would like to give you a small introduction to AI42, and then we switch back to Sine, and she'll get going about our programming language. So see you later, Sine. Hi, and welcome back, everyone. So, the motivation for starting AI42 comes from the recognition that there is no good starting material, and we aim to take you all the way from complete beginner to getting enough knowledge to build your own model. So, Håkan, would you like to say a bit of the details as well?
Yeah, sure. Thank you, Eve. So what we would like to do here is we want to like to give everyone a chance to get into this interesting field. So what we're doing is we have invited in industry experts and recognized speakers. So they will have sessions with us 2 times a month on Wednesdays at 5 o'clock Central European Time. And then we have started out here with mathematics and statistics and probability theory to give you a solid ground to stand on. And then after that, we've dived more into languages and tools. So for example, in our previous sessions, we have talked about SQL and we talked about Python, and now we will have 2 sessions on R. And after that, we'll look more into tools like Power BI and Databricks. And then we'll go into more details like how can you set up your own machine learning pipeline, and maybe more advanced topics like reinforcement learning and deep learning. And in addition to these theoretical sessions, we will also have more practical workshops where you can put this theory into practice.
Yes, and you will be able to connect with all the best-in-class experts from all around the world that will hold you these lectures and workshops with really rich content. And you can follow us on Instagram, Twitter, and Facebook. You can find our recordings from our previous sessions on YouTube, and you can get information about our upcoming sessions at Meetup. We also create cross-collaboration with other organizations, so we can give you the best opportunities to broaden your network in the AI and data science communities. So we are in close collaboration with Global AI Community and C# Corner. And hereby I also want to say thank you for our sponsors, Microsoft and Miles.
Yes, and as Eve said here, we're in close collaboration both with the Global AI Community and the C# Corner. So you will be able to see all of our sessions are recorded both on our own YouTube channel, but you can also find them here on the Global AI Community channel and also on the C# Corner channel. And we would also like to thank Mina Marie, who has composed and performed our intro music, and all of the graphic design that you can see here throughout the stream is developed by Levente Pongor. So thank you so much. Thank you so much to him.
And before we switch back to Sine, we want to say a great thank you to all you guys for joining us today again. Please remember to follow us on Twitter or Facebook or wherever you want. And remember to sign up for our meetup group as well, so you get information about our upcoming sessions as well. So shall we get back to Sine?
Yes.
Thank you.
So great.
And yeah, such a great initiative you are having. Yeah. All right.
It's nice to see you back.
Yeah. So should I just start?
Yeah, you can.
So before starting, I wanted to have a little bit of a chit chat about what are we going to talk about actually.
Yeah.
So what are we going to hear today?
Okay, yeah, I actually have it in my slides, but I can just briefly tell it, then it will be more lively probably too. So we are going to have a very introduction to R and a bit about some of the basic coding programming concepts that we use in other programming languages as well. So those of you who are maybe already experienced programmers and so on, you can maybe lean back and maybe get some inspiration on how you can tell it to others, or maybe you can just
whatever. They can always follow you, right?
Yeah. So today will be very basic on all the variables and what is called variables, vectors, and data frames, and what we can do with these concepts and how we can when we are working in R, and also a bit, of course, on why we are choosing R now and then. Yeah, instead of Python, for example.
Yeah, well, thank you. And some practical information is going to be shared on the chat during the session. For example, there will be some information shared about setting up your own R studio as well, so you can work together with Sine during the session and write your own code in R. And on the other hand, please remember to post your questions in the chat so we can answer them throughout the session and in the end as well. So let's get going.
Yes.
Are you ready, Sine?
Yes.
Yep.
And take it away.
Yeah, so Sine, before we start here, you could just share your screen.
Yes, I'll do that. Like that. And I'll do it like this, and you can see my screen.
Yeah, one moment here. We can't, not yet here. Maybe try to share your.
Yeah, wait a minute.
Once again.
Yeah, I do it now.
Okay,
I
now
just
it looks
lost.
good.
Yeah,
Yes.
So
I
we're just
forgot
gonna
the last
have
step.
we're just gonna have a little bit of music here before we start here.
Okay. Thank you. And also thanks for the interesting introduction, and really feel free to ask questions and also give comments, because I'm curious on how this will actually work today. And I'm going to do a follow-up in a couple of weeks. So therefore good input for improving is really nice. So as we talked about, I'm the author of Kvindekenning Kode, but I'm also a researcher at CBS, where I'm doing research in data science and citizen data science. And also I actually have a PhD in AI. That's like 10 years ago. But it's and the kind of AI I worked with in that time, it's the old symbolic AI, which is more on logic and rules and so on. And I worked with, for example, something called description logic. But I'm more data-driven now, so I work much more within the area of the data science. I've been working with genetics and the genetic data, and that was really huge amounts of data. And then I have been working with educational data the last 4 years. So that's my areas, and I've also been working in a publishing company. We made tech books, so that's also why I got the inspiration of actually writing a book myself. And I'm sorry that I haven't full presentation mode, but it makes it much easier to switch back and forth from my code and to my presentation here. Why should you use R? So I have to start with a small sale speech here. So it's particularly for statisticians, it's great. It has many functionalities, and it's open source, and it then has a lot of more functions than, for example, Excel does, and so on. If we look more into why should you, for example, choose R instead of Python, usually maybe when you're doing deep learning and so on, you should use Python. But it has some very elegant functions and so on, particularly within the stat area, which where you can write a lot of things in using very little amount of space. It's also, some people say that the first learning steps are easier than in Python. I don't know if that's true, but I have just taken it with it. And you can also do some amazing visualizations of all kinds within R. And also there are also possibilities of making dashboards and more automatically generated files and so on. And last thing, that's actually also a really good reason for working with R is that there is this environment, R Studio, where there is both an editor and a lot of other things. And I'm going to show you that in a minute. So here is the plan. As I said, today we'll look a bit about input file formats or reading in files and so on. It's one of these things that are challenging for many new programmers, actually. I once had a course where I should be teaching R, but it took most of the first part to actually read in files, because there were a lot of different ways to do it. So I have tried to make one foolproof way of doing it now. Always dangerous to say that. So we are also trying to calculate a bit some arithmetics in R. We are going to look at the data frames and also a few functions. And then next time we'll go more into functions and modeling, actually doing some linear models and so on, to prepare for the third time, which I'm not teaching, but it's my old colleague actually, will be teaching that one on machine learning and so on using R. And I'll also go a bit into how you can visualize in R using ggplot2, which is a package that you can use. All right. So, as I said here, to get started, you can watch the 2 videos that we have applied. I'll just show you very briefly what I did in these videos. But that's just something you can return to afterwards if you are very new to programming. I also have some resources here for you that you can use. There are both many good cheat sheets. There is a very good book called R for Data Science. And then there is a Danish site for those of you who are Danes, which is called R Guide, and it's by Erik Garner. So there is so here's a bit of resources. And this is, and I know now where we are online anyway, I know there are people from outside Denmark joining, and I think that's hilarious. Okay. Yeah. So maybe I should just, now I have opened the ball talking about our studio. So I will start here, just showing you the interface. You will probably, we'll just make a new script here. When you open R Studio first time, you'll probably it will probably look a bit like this. So there will be no your environment will be empty, your console will be empty, and you'll have no maybe you will not even have a script, but then you can just write new file and then press R script. So, and in here you can write your code. So I have written some already here up, some very basic code, which I hope is big enough for you to see. I have tried to zoom in a bit, and there is a few things you can do when you are going to have things running. You are putting your cursor here just on the line, and then you press the Control Enter. And then you have, here you can see you have an X with the value 3. So we have put 3 into the variable X. So that's and that's some very basic things that is like a something that sometimes take a while before you have done that. One thing you could also see here is that it's not only here, you can see that X is now 3, so it's kind of stored in here. So you have your data, whether it's a variable or it's a table or whatever, you have it in here where you can see it. Also, you have it here in your console, where you have put an X equals 3. And you can also, if you want to, you can also take this whole data frame, this whole chunk of code, and then run it by pressing Control Enter. And then you have both a vector called V and a data frame here called DF. We can look at this by just pressing over here, and we can see here what this data frame look like. Great. So I'd like to say a little bit about these things. Now you've just seen me throwing around with code, but it's what I've tried to talk about is that there are both data structures like a vector or an atomic variable or whatever. And then there are also data formats, and I think like data format types are like different ingredients. For example, when you're baking muffins, it's important that you blend the wet things together and the dry things together. So it's like if you try to take a text string and add 2, you'll get some troubles here, right? Whereas if you take 3 and add 2 to this, then you get 5, and that's really nice, right? So so it's important that you are aware of which data formats you have, and that's also what can sometimes be a bit annoying in many programming languages if you have the wrong data type and you try to do something with it, then it maybe don't do what you want it to do. Then finally, there is something called functions. If you have already been at the Python course and so on, of course you know something about functions, but they are pre-coded stuff that does things to what you have been working with. So it can be it can, for example, here I have just for fun said like this is a whiskers function. So when you are, I don't know, you know what it's called in English, but when you're turning your dough, or when you're trying to mixer, yeah, when you try to mix your dough, you know there is kind of a mixing function that you need, and I try to say that's a bit the same here when you are working within R. Then you have several functions that does things. It could be like it can make a statistical test, or it can transform your data, or so on. So there can be a lot of different ways a function can work. And R is very function oriented, so it's also easy in R to actually write your own functions, or easy. I mean, I'll not teach you how to write functions right now because there are so many that is already made, but that is definitely a thing. All right. So that was just a very high-level introduction of data syntax in R. So you could think of it a bit like a grammar, where we just looked at atomic variables, vectors, and data frames in the coding. So this is like an atomic vector wherein we have put in tree, and this is an atomic variable. This is what we call a vector. And to actually make a vector, it's not enough just to have 3, 5, 7, 9, and then you have a vector with 4 elements, which is these numbers. You'll need to put this little c in front of it, so that that's also a function that turns this into a vector, which is like a list, but just it's a bit like what you would think of as a list, but where you will define each the position and so on of each number. Then we have data frames, and they can be looked more at as like a matrix. And here we have actually just made it from a matrix function, where we have decided that there should be 2 rows. And as we see in here in the code, we can look at it, and certainly, yes, there are 2 rows, and then there are 3 columns, which are called x1, x2, x3. That's not something I have called them. They R just gives them the name. Yes. All right. Oops. So there are also different data types, as I said, and it can and it can be structured many ways. It can also be structured at dates and so on. But in general, there's these 3 main data types: numeric, characters, and factors. Where numeric, that's numbers. It can be integers, but it can also be doubles and so on. Characters is like text strings, like this is a character. But then there is a last version, which is factor, which can be both numbers and numeric, or it can be represented by numbers, a text, or so on. But it's usually something, for example, when you're, say you work with a survey and you have 3 things that you can have in a drop-down menu. You can are you between 20 and 30? Are you between 30 and 40? Are you between 40 and 50? Are you between 50 and 60, and so on? So there is these categories, and you can say, and then these would be stored, or it would be reasonable to store these as factors. But you can choose, and you can also turn them back and forth from factors to characters and so on. You cannot always turn them into numeric, because then you will get an error. But in your data frame, but you can try, and we'll of course try that out. All right. So just a minute to the first question session. So we're going now to calculate things, and of course you can do that, and I'll just error checking here. So we can do a lot of things. You can change format of variable, as I just said. We can also add minus, we can multiply and so on, using common symbols for that. And we can take square root, we can take logarithm and potential calculations and so on. We can lift numbers. So there are a lot of different things you can do. I'll just show them here, some of the things. So now we have our data frame, our vector, and our atomic variable here. So up here we have our vector, which is now numeric. We can even see it here, but we can make it into a character now. And then our numbers are now not numeric anymore, but they will be treated like text and so on. And for example, if we have this data frame, we can see here, we can make everything of the data frame numeric. And then let's see what happens. That's not true. I haven't made everything in the data frame numeric. I have actually only made column 2 numeric here. And let's look at this. What happened? So as you can see here, we look at the data frame. I have written this function structure, and I'll show you a bit more on that later on in the lecture. But here you can see that the first column is now a character, the second column is numeric, and the third column is a character. And that makes sense, you know. The last one here really makes sense. Yeah. One thing I like to also show you before your own exercises, then how now we have put things into variables, right? Now we want to get data out again, and that's actually not that hard. You just simply write it here like x. We just run it, and here we can see, so x is 3. We can also print x. Again, we get a 3. We can also take the first element in our vector, here 3, and you can see now there is, I don't know what these are called, hyphens, around 3 here, which means that this is now a text and no longer a numeric. Yeah. Then there are, you can look at, for example, here you have taken second row, second row, first column. Yeah, that was correct. Second row, first column. And that's simply because that's how data frames are structured. And I'll say a bit more on data frames in the end of the lecture. So just accept that there are these 3 ways to get the information out of a data frame. And these ways are actually the same, right? So this one looks very much like the first one, except for one is changed with the name from the label here. All right. So that was maybe I should just show the calculations. For example, here we can make a new variable y, where we say x times 2, and we know x is 3, right? So we do that, and now we have y, which is 6. We can also take our vector and say vector times 2. Now we have the problem that it's as a character, so it won't work. And that's a quite important thing, like what we talked about before, like you have to have the right data type to be able to do the things that you need. So if we did like this as numeric, we have no longer any errors. And we can see that this vector will be made of 4 numbers, which are 2 times the one before, right? So you can do all these things. You can take, you can also take rows in a data frame and do stuff with. You can take columns in a data frame and do stuff with. So you have a lot of opportunities here now, and all this data is stored in the memory. So you can do so many of these row and column operations are really fast to do. All right. So we are now at our question session. So if you have any questions before we go to a small exercise that I'd like you to do, or we can do it together, of course, but I think it's good if you have your computer with you, that you try it out a bit, because or else you have just forgotten it after this session.
Hi, Sine. We have questions.
Yes.
The one is, what's the difference between your data frame and your metrics?
Well, so a data frame has a bit more. I think it has a bit more functionalities, and you don't know if you store. I'm not. I don't know all the details on that. But usually, when you work with data in R, you store it always as a data frame. But you can put it into a matrix format, which is like a very simple vector format, right? So I actually cannot give a very good answer on that. Maybe someone else knows more on that.
Isn't it like that data frame format is mostly like a column, like the column-based data set? So it's like having like columns and such, and matrices are more like a bunch of data just to...
that's also what I'm thinking.
Not necessarily relational like this, but the whole thing.
And you can make row names and column names and stuff like that in the data frames.
Yes.
That was a good question, actually.
It's Stephen says that data frame is a list of equal length vectors.
That will.
So our language has several packages for solving a particular problem. So how to make a decision on which one is the best to use?
I think there are many things in it, and actually, there are both what programming language are you good at? So it's also what do you which programming languages do you prefer to work in, and do you have a good intuition about, and so on. So that's one way to decide. But there is also you can also try to see if you are going to work with it in industry, for example. So what are the in that industry, are they using more R? Are they using more Python or other things? I mean, usually R would be a better choice than many of the commercial tools, but because it can take all input data formats, as I showed in the video, right?
And that can also be a good practice.
Decision.
Sorry.
So that has of course nothing to do with this. But what is good about R particularly is this that I mentioned before, that it's very good at visualizations, and it's very good at when you have like these huge tables, you can do a lot of operations on the columns and the rows and so on. Whereas in many other languages, you don't store data that way, so it will be a bit slower. Then on the other hand, there can be other things that are slower in R. There are some of the deep learning algorithms that are maybe more optimized for Python, for example. Yeah. Maybe other people have suggestions as well.
I would say also that actually it is a good practice as well. Like Stephen also mentions it, that for example, it often happens that some packages from R is used in Python code because R packages are used for something else, or for example, especially for very long, the graphics, the graphical visualizations and whatever were looking much better in R than in Python. You could do like a 3D stuff and whatever. That was, for example, one of the reasons why we would use R for visualization rather than Python packages. Sorry. Yeah. Going back for one moment to this data frame versus matrices, I am not sure if that is right, actually, that data frame is equal length vectors, because if you think about it, I think matrices are more ruled into one specific schema. The data frame can have empty columns as well. But
yeah, I'm also just thinking of data frames as something where you can name the columns and name the rows and so on. So you can so you have more options there. Yeah, but I have to look into this till next time.
Yeah,
because that's there might be a lot of small details that are
for sure.
that differs. Yeah.
All right, I give it back to you.
Thank you. So so now we should have a small exercise where you in our studio should try to create a single variable and a vector and a data frame, and also maybe try to change data type of variables, just as I have done, and do some calculations. So just if you could just try this and keep you just open R while we are I keep on blabbering. So here try to for example put in some data to atomic variable or vector or a data frame, and try to do some of these calculations on the variables. So, and this is of course much easier when you have some kind of interaction with people. So, so I'll not stay too long here. But it's just really nice to have tried these things out for yourself. Please let me know if you have any questions to some of these practical things. Now I have stuffed this with a bit more code than you need to actually do the exercise, right? Sometimes you also can see here, if you start to write a code, then you can get it, and then you can just press on it, and then you are sure that it's spelled correctly, because that's a thing in programming, right? That it's so easy to spell things wrong. One thing I should also say is that you can use this help function over here, and I'm just talking while you're trying things out. For example, you can look at as numeric. And look, so how does this work? It's a bit boring, right? You have just just have x as an input, and then you can even take how much you can use the length to define how much of it should be numeric. So here you can see, for example, some examples, and that's and the built-in, something I would also like to say about the built-in help function here is somehow okay. You can see the usage up here, and you can look at the arguments here, and you can get an example here, but I don't always think the examples are actually really good. So one thing I would do is actually to look at Google for this one, and and then I'll find maybe an answer at Stack Overflow if I want something more advanced. So that's really a good place to go to try to Google your question, and sometimes you find the answer in some R material, and sometimes you find it on Stack Overflow or other places where other people have asked the exact same question as you. And it's amazing how some weird little niche question that you think nobody else are interested in this thing, you just write this, for example, R numeric length R, and then you figure out that there are a lot of people who have done that. So I hope you have played around a bit now. I'll go on with functions. So function is like this mixer function, for example, the dough mixer function we talked about before. If you should take it into something real, but here it's an operation that does something to your data normally, and you can build your own function. I'll show you today. You can borrow one from the internet, for example, if you have this little niche question that you want to pose. Quite often there are some nice people that said, oh, I have solved this by writing this function, and then you can reuse it on your own data, and you can see the code, so you can also see how the function actually works. But we are not going to look at that today because I thought that would be too much. So we have some examples of functions. So else numeric is a function. The C is a function. Read Excel is a function. That's if you're going to read an Excel file, which we'll do in a minute. So there are different ways here. Also, for example, Ttest. A Ttest is a function. I'll try here to show some of the arguments. And this one is from the help function. So if I can just show you. Here we have this written this way, and it's except if you're really good in R, it can be a bit impractical to look at this, and then actually it can be maybe even better to then Google Ttest example two-sided or something, and then you can or alternative equal this or something, right? And then you can then you maybe can get some better versions of this. Of course there is still an example there are examples in the buttons, but that can sometimes be a bit hard to interpret what's going on here. All right. So do you have more questions by now? If not, I think it was a very short session, I agree. Then we'll go on. There I have made a small exercise here too, where I try to look at, there is a function, this Ttest function, and you can, for example, write these 3 lines of code, very simple. So you are taking, you're creating some normal distributed 10 points of normal distributed data and put it into X with I think it's with a mean 0 and a standard deviation 1. And then after this, you do a Ttest on these 2 variables to see if they are equal or not. And you can just a moment. You can just look at our rnum to look at what it is. And yes, I was right. It's you're creating some numbers with the mean 0 and standard deviation 1, some random numbers, and you have two different. Here you have. So now we have both x and y are vectors, numeric vectors, as we can see up here. 10 points, and you can see here they are around 0. We can create a t-test to see what's here. So the t-test things really cannot exclude the possibility that these two are equal. That's what it means. So if the p-value is below 0.05, usually you say then these two vectors are not the same. But well, they seem to be very close to each other, and you can also see that they should be, right? Because they are. I mean, maybe if you're doing enough random examples of this, you'll actually you'll maybe find now and then that they are differing. Yeah. So the exercise here is try to add 5 to the x value and then try to do a one-sided t-test. So that's the exercise that you should do. And I think we'll try to do it together now, because since we don't have this interaction thing where we can chat about it, it's maybe better that we go through it together, right? So you can, so I made a new code here where we are, not to confuse you too much, I have do like this. So now we add 5 to all the values in x, and we make a y here, which is just with a mean of 5. And then maybe we should start with making the common t-test here. So what can we see here? So now they are definitely different. So and then if we are going for the greater, we can see this is also different, but it's a bit, the p-value is even smaller than the p-value of the two-sided t-test. So you can see that that one-sided t-test with alternative greater is better. And I've just I always forget these things. So what does it mean? So I have written it in my slide. and the other one here, when you look at this, the output here, you can see the p-value is equal 1. But you can also see here, the mean is 4.5 of x, and it's a bit more than 0 for y. So it should be different, right? And the standard deviation you cannot see here is equal 1. All right. So and I'll just find it here. So if you say less, then the hypothesis is that y is smaller than y. Y is smaller than x, and greater means the other way around. And the thing is, so you could say, but it is, y is smaller than x, and that's true, and that's why the p-value becomes so large. So usually we try to formulate it such that we have a hypothesis we can reject, such that H0 is a hypothesis that we reject. Yeah. All right. So, but that's the stat, and I'll not go too much into it. I know you have already there have already been some sessions here in AI 42. So if you want to get more into it, you can rewatch these sessions. All right. So do you have any questions now? I have maybe been playing around with the exercise. Please let me know. All right. So I'll go. Eva and Håkon, are there more questions? All right. So I'll just go on here. A bit more on data frames. We'll rewatch these. So here is an example where we take this matrix and put it into a data frame. So we need, if we want to read in files, we need a library. And we also have different tools to inspect these data frames. So I'll just go through what I have here. And then we go into to the last coding here, where we're looking back in our RStudio. So typically a data frame is structured such that we have rows on the first. So the row number here is the first part of the space within the squared brackets, and then we have the column number afterwards here, like this. So we can also access data in another way, for example, using this $sign. So here we actually have a vector, which is the column. For example, here we have a vector with column 1. And then we can even, if we want to access a row within this, we can do it like that. We can put a square bracket afterwards. So that's the two way you can actually, there'll probably be others, because sometimes, many people, they have made new functions in R. But these are the two that are mainly used. So as I said before, there are here are 3 different ways of actually accessing the same, which is column 1. Right. So let's go back and look a bit more into our old friend, the data frames. So now we need something called a library, and that's actually a package. We use library to access the package. So library is a function that opens up a package. And sometimes if you don't have the package already, so I have, then you can go in here and press on install, and then you can install it, right? Oh no, I'll just, yeah, it was fast. That was good. I didn't try that before. So sometimes it can take a while to install packages, right? So after we have installed it, it will be here in our package, and it's installed on the computer now. So the reason for not taking in all the packages in the world is that they will take up quite a lot of space. So install the packages when you need them. Just like you only load in the packages you need. I have a bit, you can also load a lot of packages in, if you sometimes use this package and sometimes use the others, you can just put them all in the beginning. But it's a good habit to only use the libraries you need, because it will take a lot of space to actually load them in. So, but let's see if we can now access it. Oh yes, but now it warns me. Sorry, it's in Danish, and it warns me that this package is maybe a bit too new for my R version. So we are very, very curious if this will go on, right? So, but we try to put in. We have our data frame, and we can, for example. So what I have done here, we're looking into it. I have not. If something is a factor, then you'll need to put it into a character first, and then as numeric. I think there are some new packages that does it smarter, but this is just something you can always do with the base R installation, which is like the common libraries that are always in R. Whenever you have, whether you have downloaded other things or not, there is a library of base functions. So now I have only run this one because I think it's fun. Then we can look in the different types here. So we can look at when this function view data frame, then we can see it here, and we can see it looks like these two have different are different data types somehow, right? But we don't know, and we can see over here, hello world. That's definitely, that looks like text at least. Then we can use this one that gives us a bit more information. Here we have the structure of the data frame. Here we can see that x1 is numeric, x2 is a character, and x3 is a character. So x3 is a character, that's just great. But that x2 is a character, that's a bit stupid. So we don't even need to press it into a character because it's already a character. Then we can do like this. I just ran the code, and then I'm running this structure code again. And now we can see it makes sense now. So there is a numeric, and then there is a character here in row 3. Then there is I mean, there are more ways to inspect data, but you can also, for example, look at the summary here, and you can see that the first column here with 2 values, it takes an average so that you can get the mean, and you get the median and the max and the minimum. That can be really nice to have this overview if you have a data frame, for example, of a survey with Likert scale questions. You can that can be nice, and a lot of other good reasons for making this summary. Then we have some new friends here, so I just have to see, where am I? Oh, I'm the right place. That was good. So now I can just do like this, and I read in my files. But this is what always goes wrong, because we need to be in the right directory, working directory, to do that. So one thing that will always work, if we put here, it is to import dataset. And the first dataset here we need is a CSV file. So, and that's equal to a text file. And it's this one, as far as I remember. And here we can see down here, this is the input file. This is what it looks like in a data frame, right? Where we have names of the columns and so on. We can see here that it understands that the separator is a comma, but we can change it if we think, but it's wrong. The separator is really white space. Oh, you can see now it looks weird. So we go back to comma. And there are a lot of other things you can set here. Row names, you can also make use first column as row name. No, it won't allow us to do that. Maybe use numbers. It hasn't, but we'll try this and see what happens. Also, we say if there are some strings that are empty, it will put in NAs instead. And we can press this on string as factors. Then all the strings we put in are factors, but can also just have them in as characters. That will now the strings will be loaded as characters. For example, region and country codes and so on, and disease. So this is from data from WHO. There is no corona data, COVID-19 data in it. It's only measles and other stuff of other kind of diseases, right? So we now import it. Interesting, yeah. So and what's have been done here is we have used this code, and then just for the next time we're going to use it, we put in this long path for it. Right. And instead of that, we can of course just have a workspace here where we put in the data. So if you're interested, I can show you a bit on how easy to make a new project folder where you can just, so that you don't have to write all these things, but you're writing like this. I'm just curious if I actually did anything with this row names. Since it's numbering, it's difficult. Try to say that I would try to do a bit of stuff. No, we cannot. We're not allowed to do that. It could. But these things are things you can try out again yourself too, right? I have another table here, which is an Excel file, which is also easy to read in. And as you can see here, you can also read in files of other formats from SPSS, for example. I think SPSS, interesting thing is that SPSS files are not called .SPSS, they are called .sav. But that doesn't matter. R takes it all. Also data files, also SAS files, which is really a nice thing because SPSS won't take R output formats, or it won't take data output formats, right? So these are commercial, and our developers thought, well, it's really nice to be able to actually read in these files. So they made packages for that. But we are going to take an Excel file here, bags of oranges. Yes, and here we can see it is a bit different, right? But here we can see that bag number, weight, and price, they are all called double, which is a number format, and origin and food label is character, right? So we can also change it to other things, but we'll keep it like this. It looks good. The default sheet, but you can also take another Excel sheet if you rather want that, but we keep on this. We can also say if for example, if you have some data in from some pivot or something, you might skip some row numbers, maybe the two first. Then you can see here. Then we have simply skip the first two rows, but that's not what we want. You can just. All right, so here we have the code, and what I will do is actually not read it in. I'll just take the code here because I'd rather have a shorter name for this file. And you can see here that it's the same code as the one I wrote before. And let's. So the first thing is we look at how many. We are going back to the WHO file. We look at how many rows are there. There are quite a lot, 43,000. We want to look at it. We use the view function. So here it opens up here, and it's a somehow Excel-ish filtering thing where you can actually sort. You can also sort, for example, here by year. Here's the oldest, sorry, data, and here is the newest data, and so on. So you can use this a bit interactively. Then there is a structure which we looked at before, and it's just like when we read it in. So we have here, these are all characters, which is nice. Then we have year is integers, and finally we have these number of cases, which is numeric. We'll try to do a summary here too. And then we have it's not very informative on the character ones, but it's informative here on the you can see, for example, and also maybe not for a year, but then you can see here that in general it seems to be very biased. So there are a lot of zeros in it that are included, right? So the zeros you could exchange with the NA if you wanted to look at look at these diseases in countries that actually has counted any, right? So that's something you could consider to put these into an NA value, but I'll not do that now because we're already over time. All right, so just a little bit more how we can expect these data frames. We can, for example, we can look at, so now so what I'm doing now is I'm just putting the cursor over this code that I want to run. Then I press Control Enter, and then the only thing I get here is this function that I just put my cursor over, right? So we can see here we have these are the unique diseases. So we have 43,000 rows, but it's only with these 7 diseases. If we are not sure how many there is, we can use the length function, and then we can see how long is this. Yes, and also, for example, then you can see how many rows are there again. So that's that didn't gave us any new information here. But we can look at, for example, the maximum of cases. Well, that's this value, which is many 1 million cases, and we can see over here from our summary that this is equal to that one. So if you just want the max value of something, then you just use the max function. And there are many other functions here, and that's a problem sometimes about introducing. There are so many functions you want to show, but this is a few. And then I'll go on with a not so introduction to R next time in some weeks. But please give some inputs to the session, then I'll refine it for next time. Yes?
Hi, welcome back, Sine. That was amazing. Thank you a lot. Yeah, we had some questions during the session. I think yes. Some people also followed you with coding. Mm-hmm. So those who have followed you, could you guys shoot us a message so we can see how many of you have how many of you have written code with us. For the next time, Sine is coming back with some more hardcore introductory to R, and we are going to share more links before that where you can prepare for that session, because there you will also have the chance to write code again. Also, Sine, are you able to share the code that you wrote today? So yes, those who couldn't keep up, then they can also try it out.
Yeah, definitely. I'll clean it up before I send it, right? Because now I just added in a lot of stuff into it. So that it follows kind of the slides. So I can send out both slides and a code structure. So yeah, that's our code.
Cool. Yeah. Thanks. I understood what you mean. So it's all right.
Yeah, it's a code structure. Well, there is not really any structure in my code. So that's a thing in R also, that you since it's just one-line commands, it can also sometimes be you need to do some things to structure it, right? Having comments and so on into it.
And I remember that was always interesting when I started to look into R, that it was really funny that for the first time I didn't know that kind of notebook environment, and when I ran the notebook, it ran everything from the beginning. And so that is pretty big problem when you do like advanced analytics with like 100 lines of code, and then it starts again from the beginning because you forget to choose only that line that you want to run, and it starts from the total beginning, and you're like, oh, come on, Eva.
You have to have a cup of coffee, or
yeah, and you go out for a coffee. Yes. Yeah. So we got an answer that someone actually managed to follow along with you, which is pretty good. That's nice. So we hope that next time the people can follow you again. We will make sure that we are here with Håkan to support, so that attendees who have any problems, they can ask us, and we try to answer also when you are deep in your code. So when do we meet again, Håkan?
Yeah, so next session is on May 5. So then we'll meet with Sine again with follow-up to this session. So with that, I think we can thank Sine, and we thank all of you who has been watching this stream live, and also for those of you watching online.
Yeah, and so it would be so nice also. Actually, also would like to have some input on the level if I'm going too slow into this or so on. Or
I think you did
fast.
Great.
Yeah. Okay. Yeah, but I'm interested from people who are listening also if what they thought about it. Yeah.
Yes. So all the people who attended us today, please remember to follow us on Twitter and Instagram, and follow our meetup page as well. And there, that would be great if you could write a comment. What did you think about today's session? So Sine could bring in some more exciting stuff for you. And we meet on the 5th of May, about which you will also hear at our meetup page. So with that, I want to say a great thank you for our attendees for joining us, and for Sine for the awesome session, and Håkan for all your help during the stream.
And I have to say thanks for the great initiative you're taking. I think it's awesome. And thanks for all the coordination, because, we are just jumping in and telling what we know, but I know you are doing a lot of stuff in coordinating us.
We're trying to do the best. All right, everyone. So thank you a lot.
Okay.
Thank you.
Thank you.
And have fun. Bye.